Today, we're going to be solving radical inequalities. First of all, what are radical inequalities? Well, they are equations that contain variables under the radical. This part will be called the radicand. In this particular example, the radicand is boxed in blue. What we need to know: always check the index. If there is none, it's 2. This is important because the index is the number by which you will power both sides of the equation in order to get rid of the radical sign. In the first example, since there is none, the index is 2, has to be 2. In the second one, it's 3, but that number can always change. Now, in the first example, the first thing I did was subtract 2 from both sides in order to isolate the radicand. I then powered by 2 both sides in order to get rid of the radical sign. Then I added 3 to both sides. Okay, this is only the first part in solving inequalities. The second part is making the radicand greater than or equal to 0, which is going to mean that x is greater than or equal to 3. Now, your answer is going to be bracket 3, comma 11 bracket. This is the answer in interval notation, but don't worry about it because I will explain how to do that later. In this second example, the first thing I did was subtract 6 from both sides in order to isolate the radicand. Then I divided by -1. Okay, here you have to be careful because we're going back to rules from simple inequalities. Remember how each time you multiply or divide by a negative number, the sign is going to switch? Well, that's exactly what happened here, so you have to be careful. Now, I'm going to power both sides by 2 in order to get rid of the radical sign. Then I added 3 to both sides, and that makes x greater than or equal to 19. Then what I did was I made the radicand greater than or equal to 0, which means that x is greater than or equal to 3. Now let's take a moment to think about this whenever we write the answer. If x has to be greater than or equal to 19, which means that at least it has to be 19, that means that it's going to be greater than or equal to 3 by default. Therefore, your answer can only be 19 or greater than that. Therefore, it would be from 19 to infinity. Now, in this next example, the first thing I did was subtract 1 from both sides in order to isolate the radicand. Then I powered both sides by 2, since that's the index, in order to get rid of the radical. I then subtracted 2 from both sides, and then I divided by 2. Now here you have to be careful because check out the sign. It's different from the other ones because this one is only greater than. It's not equal to, just greater than. Now, I made the radicand greater than or equal to 0. I then subtracted 2, and then I divided by 2, which means that x is greater than or equal to -1. Now here, if you draw it in a line, you're going to see that -1 has a closed circle. That's because -1 is less than or equal to x. So whatever the sign is going to determine whether it's a closed or open circle. Now check out the 7. It's an open circle, which means that the sign was only greater than or less than. In this case, it was x is greater than 7. Now here, let's think about it. The answer has to be greater than 7, but not include 7. Therefore, it has to be greater than or equal to -1 by default, which means that your answers will only be greater than 7. So therefore, they have to be greater than -1, if that makes sense. Therefore, your answer will be parentheses 7, comma infinity parentheses, because that way it represents that it has to be greater than 7 without including 7. In this next example, check out the index. It's different. It's not 2. So the first thing you're going to do is you're going to power both sides by 3 because that's what the index is. Then you got rid of the radical sign, and then I subtracted 2 from both sides, and that makes x is greater than or equal to -1. I then made the radicand greater than or equal to 0, which means that x is greater than or equal to -2. Therefore, your answer will be bracket -1, comma, infinity, parentheses. Now here the same logic applies. If it's going to be greater than or equal to -1, it has to be by default greater than or equal to -2. Therefore, the answers can be either -1 or anything above -1. And you can see it in the line. All the answers will be in the part that is boxed. Now, to check if your answer is right, all you have to do is plug in any variable from your answers to make sure, but make sure that it isn't in parentheses, because if it's in parentheses, then it shouldn't be able to work. Okay, for this equation, we already have the answers. So the answer is either 3 or 11 or anything in between those. So I'm going to choose a random number in order to check this. So the first thing I did was I plugged in 4 for x. So then the radicand is going to be 1 plus 2 is less than or equal to 5. So then once you do this, you're going to get 3 is less than or equal to 5. Now you have to take a moment and think about it. Is 3 less than or equal to 5? Yes, it is, which means that it's right. Now, in this example, the answer has to be either -1 or less than 7. Okay, so what you're going to do here is, I want to show you how it is important that you watch out for that parentheses. Because look what happens if I plug in 7. Well, first of all, you're going to solve it. So we all know that that 16 is a perfect square root, so that's going to be 4 plus 1 is greater than 5, which is saying that 5 is greater than 5. Now let's think about that. It's not, especially since it doesn't say that it includes 5. If it included 5, then it would be right, but since it doesn't, then that answer is not true. So that means that you would have to go back and recheck that. Now, how to write an interval notation? Well, for this particular equation, we found that both parts in order to solve the inequality, and that's that x is greater than or equal to 3, and that x is less than or equal to 11. Well, the first thing I did was I made a line and put both numbers, 3 and 11. I then looked at the signs because that's really important. And since they are both greater than or equal to, or less than or equal to is the key word there. Therefore, they have to be closed circles. Which means that if they're closed circles are brackets. That's why you write a bracket 3, 11 bracket. Because that means that 3 and 11 are included in the options for the answer. And that's how you do interval notation. Another example is this equation. Okay, in this equation, what I did was I chose one where the sign is only greater than and the other sign is greater than or equal to. Now, if you draw the line, you put 1 and 7. Since 1 is less than or equal to x, it's going to be a closed circle. Remember, equal to is the key word. Now for 7 is just less than x. Therefore, it has to be an open circle. Now, the answers here will be greater than 7 to infinity. So the answers will be, you can find the answers in the boxed part of the line. but it cannot include 7 since it's an open circle. Therefore, when you write interval notation for this, remember that the sign is represented by either a bracket or a parentheses. And in this example, since 7 is the least number that you can have, but actually it can include 7, so that's why it has to be parentheses 7, comma, infinity. Now, in order to write it as an inequality, the answer for this particular equation is x is greater than or equal to 3 and x is less than or equal to 11. Well, all you're going to do is pretty much put those two together. So 3 has to be less than or equal to x, but x has to be less than or equal to 11. So all I did was put those together. Notice how for the 3 and the x, at first it says that x is greater than or equal to 3. But whenever you put them together, x is still greater than or equal to 3. The only thing I did was that I put x in the middle so that it's continuous. And that's all you have to do to write it in inequality notation rather than interval notation. So that's also a real answer. You can write it like that. And that's pretty much it for this. Thank you very much for watching. Have a great day.